Welcome to lecture 26. So in the last lecture we have learned about different storage media and their hierarchical structure, about some of the devices are in the primary storage media, some are secondary and some are tertiary. So today we'll go for some strategy of how different storage media are working together whenever they are in NAS or in SAN network. In a NAS or SAN network, the devices are connected to each other. Mostly the storage devices are interconnected. So whenever a much storage devices, so many system today needs to store many terabytes of data, like Facebook and social network, they have a lots of images and videos, YouTube, these sort of things. So whenever you are using a lots of data, terabytes of data, and you think that a single disk or merged disk is not a single solution, because if they are also give you some guarantee about protect your data. So if some server is totally crashed or a hard disk is totally crashed, data should not be going down. So there should be some redundant copy of the data to different geographical location or the same location with different servers. So there are two things there we have to calculate here. That is the expense of preserving the data. That is one thing, and another thing is failure could be catastrophic. So this is the point where the data are splitted and kept in different geographical location, and also it is focused on how expensive the total system will be covered. Now if we're looking for a technology, it is called the RAID. In most of the technology, hard drive based and database, they are following the RAID technology. In the RAID technology, it is RAID. It's been redundant array of inexpensive disk. So it is an array of disk and which are basically inexpensive, so they are not following the expensive solution. Suppose like if you are buying a 10 terabyte of hard drive, it costs a huge nowadays, right? But if you are focusing 500 GB 20 hard disk, this is cost lower than a 10 terabyte of hard drive. So if you are making an array of 500 GB 20 hard drive, an array, then you are connected with some peripherals or other interconnections. So that is also having the combination of preserving data of 10 terabyte than a single disk. And another perspective is all of the 20 disk will not be fail in a single moment. Okay, so there may be a fail of a single disk, which is basically incur the loss of 500 GB. But if your 10 terabyte of disk is lost, then total 10 terabyte data will need to be recovered through another 10 terabyte of disk. So that is the mainly the calculation part of the largest storage capacity and the redundant of the data accessibility. So many different levels of RAID system, different corporate companies and different associates are using different levels and different system of RAID. And the thing is that basically the RAID devices are can be software maintained RAID, can be hardware maintained RAID. So different type of things can be propagated, and different level of redundancy, error checking and capacity and cost is dependent on different level of RAID. So basically the technology is having the three main factor. One is the stripping. Stripping is whenever you have 4 disks, suppose like here is you have 4 disks, disk 1, 2, 3 and 4. So this is disk 0, that is first, this is disk 1, this is disk 2 and disk 3. So there are 4 disks here. So all the 4 disks are connected allow the parallel connection and having each of data. So when data is calm, so there is a mapping, there is an indexing policy. There it requires the data is preserving on these drive. Suppose like whenever you are just uploading a file in Facebook, suppose a picture, the same picture you are download after 2 minutes, you saw a different number, a image number that is having the combination of the in which server, which drive or which date and which user is uploading the data. It's a huge text is with the encryption. So we are not understanding which is basically the text set, but it having a meaning, useful meaning. So that is the stripping. When stripping means whenever you having a more than hard drive but you are combine it in a single place, it is called the stripping. Another thing is the parity. Parity is basically used for checking the error and correction. So you are using parity in probably DLD and other subjects. So what is parity is basically do, if the even number, set the parity bit to the 0. If the odd number, then the set the parity bit to 1. Whenever the data are considered and data is sent, suppose like here there are 5 ones, so there are 5 ones, that's why the parity is 1. There when the data is transmitted and transmitted like these, the parity is going to be 0 because there are 4 ones. So there are two types of two data, one having the parity 1 and another having the parity 0. So if somewhere in transmission the data is lost or the some 1 is converted to the 0, then the parity will be changed. Whenever you are checking with the original parity, then you can find out where the data is correct or not. So that is the parity basically works for basically the error checking and correction. So that is another technology. So basically if you are going for a truth table, XOR table, XOR gate, so A and B, there are two data. So if there is 0 0, then if we do the XOR A XOR B, then the result will be 0. So if it is 0 1, then 1, then 1 0, that is 1, and 1 1, it is for 0. So for even you will get the 0 and for the odd you will get the 1. So this is how the parity basically works. So in the RAID level 3 array, suppose a RAID level 3 array with the disk D0 and D1. So D0 is a disk having some data 0 0 1 1, and D1 is another disk, it's having the data of 0 1 0 1, and it also having a parity disk P, which is basically keeping the data of the parity. So it is basically preserving the parity of D0 and D1. So it is having for 0 0 0 0 1 1 and 1 0 1 and 1 1 for 0. So how can you check the data is correct or not? If you are if D1 is XORed with P, if the D0 will be back. So if the data you are having one data, suppose like D0, whenever it received on the other end but found error, so how you are calculating the total data? So if you are making an XOR with D1 and the parity P, and you will get the original data of D0. Same, if you are making the D0 XOR with P, you will get the data of D1. So this is how you can make the disk failure of the recovery system. Now another technology is the mirroring. What is mirror means? Whenever you are standing in front of a mirror, you are just seeing yourself, not other people. So mirroring is basically copying a data. So it is copying a lot of data to separated disk. If some disk having around 250 GB of data, so it is copy exactly 250 GB data in another disk. So if somewhere or some reason one disk is failed of 250 GB, So it having a exactly same copy in another disk which is preserved. So that is how it is just mirroring all the time. So it having some time deficiency, suppose like 1 hour, 2 hour, after a several time of period, it is just copying and rechecking again the copy is alright or not. So that is another thing. So we are getting here three things. One is the stripping, which is basically binding more than one or two hard drive or many hard drive in a single place. Another thing is the parity, it is just checking the errors. And third thing is the mirroring, that is copying of the data exactly. So if you are looking for a hard drive mechanism, so if you here seeing the thing, so there are in a hard drive you will find a spindle, which is basically a motor which is rotating the disk. There are some heads which is read write the disk, and some cycles. It is called the track. It is called the track. And in the circles there are some splitted areas which are called the sectors. So you have already heard about some word of bad sector. What does that mean? Bad sector means in some sector which is totally lost, or magnetically it is non-polarized. So that is why read write function isn't working on that place, because it is a magnetic hard drive. So if the magnetic pole is not working, so read write function is not working on this specific space. So this is why it is called the bad sector. So if we are going for the RAID level 0, so RAID level 0 is nothing but it is called a stripping system. Just you have a lot of block of data, and you will keep this data in like an array with some strips. So there is an important factor of mean time to failure. So you have to provide the redundancy and error detection of the mean time failure, that how many times the total system will fail. So we will cover the mean time to failure this lecture on lecture number 28. So in the RAID level 0, it is basically making the stripping. So there is some disk. So disk having there is some disk 0 and disk 1. So disk 1 having some sectors, and disk 0 having some sectors, and disk 1 having also some sectors and blocks. So these files are blocking in together, and these two hard drives are stripped. So the total 6 and 6 blocks are totally merged in a place as a single space. So it is called the stripping technology. So there are some ratio and performance issue about the RAID level 0 analysis. So around 5% of failing ratio can be happen for a RAID level 0, and performance is having some difficulties of calculation of performance of RAID level 0 analysis. So in the RAID level 1, it is just mirroring the data. It is nothing but some mirroring the data. There you need, if you implement RAID 1, you need more than one disk at least, and it is basically the completely redundant of the data. So if one disk number 1 having some data, disk number 2 having the same data, exactly same, so same to same. So that is basically RAID level 1. So if some disk having some sectors of 0, 1, 2, 3 and 4, and the 5 is now empty, so in another disk, if you are just mirror it, you will find the same data of 0, 1, 2, 3 and 4, and the 5 is empty. So this is how the RAID 1 is maintained. One disk having the same copy of another disk, so it is called the RAID level 1. So in the RAID level 1, it is also having some failure rate and some performance issue because it need more disk to preserve the same data So that is why if the hard drive or the data is lost, you can get the whole data written completely intact in the another disk. So that is the successful issue of this system. So that is the lecture. Thank you for watching.